Okay, so let's start with angle of elevation. So angle of elevation, we say that angle of elevation means that we are looking from down below up to something above us. As you look at this picture, we've got a person standing looking up at the top of a tree. So we say the angle of elevation is that angle that goes from the horizontal line of sight or the ground all the way up to the tree. So you can see here in this picture that X is representing the angle of elevation. So most of these problems we're going to do together, it's going to be from the ground up. That doesn't mean that you still couldn't do an angle of elevation problem. If you were standing on top of a mountain looking up at the sun or looking up at a bird in the sky. Again, those would be examples of that. The second one is our angle of depression. We say angle of depression simply means now we're up above an object or person, or we're looking down at that particular point. So you'll notice in this picture, and this is probably the one that students have the most trouble with because they put the angle in the wrong spot. So if I'm at the top there of the lighthouse looking down at the ship, the angle of depression is that line of sight from straight horizontally down to the ship. As you look at this picture, notice that we're saying both X and Y, this angle and this angle are exactly the same. So we can kind of say that the angle of elevation and the angle of depression are exactly the same. You remember back to when we talked about parallel lines back in chapter 3. We know that these angles are alternate interior angles. And when lines are parallel, that means that the angles are the same. So utilizing that angle when we're solving our problem helps us by putting that angle inside of the triangle. So again, be a good idea as we draw some of these pictures to think about the horizontal viewpoint down to the object. I would say the number one mistake I see on angle of depression problems is students will put the angle of depression right here where I have my pen set. I think that the depression goes from the viewpoint to the vertical line. So notice the difference between where the angle of depression is and where it should not be. So just something I want to point out to you there with that. We are going to do an example of angle of elevation first. So let's take a look at that. We'll go through one together, and then I'm going to give you a chance to work through one on your own. Here's what it says. It says at a point on the ground 39 feet from the foot of a tree, the measure of the angle of elevation of the top of the tree is 42 degrees. It says find the height of the tree to the nearest foot. So on all of these, the first thing you're going to want to do is draw a picture. And that's probably, I think, the hardest part of the problem. Once you get it set up, it really just becomes a trig problem like we did last week. So we have a tree here. Again, you don't have to be an artist here to draw a tree. So here's my tree. I know that I have a point on the ground that's 39 feet from the foot of the tree. So if I extend a little horizontal line and make a point that's 39 feet, we could say it's a rock. Just something that's 39 feet from the base. It's telling us that the angle of elevation to the top of the tree is 42 degrees. So if I draw in a line here that goes to the point from the top of the tree, that angle of elevation is 42 degrees. And the question being asked is, how tall is the tree? So we're just going to call that vertical distance x, and hopefully you see then where our right angle is in the picture. You should notice that we have the opposite side is what we're trying to find. The adjacent side is given to us as 39. So when we have opposite and adjacent, that tells us we're going to do tangent. So the tangent of 42 degrees is equal to the opposite, which is x, over the adjacent, which is 39. And really from here it becomes a calculator problem. Go ahead and give you a few seconds to type that into your calculator and see what you get. Hopefully as you type that into the calculator, tangent of 42 and then multiply by 39. And we're going to the nearest foot here, so we would say that x is equal to 35 feet. Okay, let's take a look at the second one. This is also going to be an angle of elevation problem before we move on to angle of depression. Here's what it says. It says a 100-foot wire is extended from the ground to the top of a 60-foot pole, which is perpendicular to the level ground. Find to the nearest degree the measure of the angle that the wire makes with the ground. So take a few minutes, see if you can draw the picture, and then I'll draw it up there so you can kind of compare and see that you've done it correctly. Okay, I'm going to go ahead and draw the picture, and you can kind of check to see that you're on the right track here. So we've got a 60-foot pole. So here's my pole. We've got a 100-foot wire that's connected to the top of the pole to the ground. So there's your wire. And then they're wanting to know in the question, to the nearest degree, find the measure of the angle the wire makes with the ground. So that's this angle right here. So based on the information we're given, the opposite and the hypotenuse, that's so we're going to do sine of x equals 60 over 100. And then when we type that into our calculator, again, we want to go to the nearest degree. You're going to do the inverse sine, 60 divided by 100. And to the nearest degree, x is going to be here 37 degrees. Okay, so an angle of depression, here's the first one. It says from the top of a lighthouse, 165 feet above sea level, the measure of the angle of depression of a boat at sea is 35 degrees. It says find to the nearest foot the distance from the boat to the foot of the lighthouse. So again, first thing we want to do is we want to draw our picture. So we've got water going. You don't have to be an artist here. I'm not a great artist. We'll make a boat. I'm going to go ahead and just so it looks like a boat, make it a sailboat. Then we've got a lighthouse. Now we're saying that the top of the lighthouse is 165 feet, so that's going to be my vertical distance here. They're telling us that the angle of depression from the top to the boat is 35 degrees. So if I were standing on top of the lighthouse looking straight out down to the boat, that's going to be this angle right here. as I said, the common mistake that students will do is put the angle right here. That's not right. Angle of depression is from the horizontal out down to what it is I'm looking at. Now, because that angle's there, just to get it into the triangle, I'm going to go ahead and write 35 degrees here in the triangle, because we know that the alternate interior angles are the same. Now, the question being asked in this problem is, what's the distance from the boat to the base of the lighthouse? That's this distance right here. So what I'm going to do is, I've got the opposite side and I've got the adjacent side to 35. So what's that tell me I'm going to use? Tangent. So I'm going to say tangent of 35 equals 165, that's the opposite, over the adjacent, which is x. Now this is one we talked about last week. When the variable is on the bottom, we're going to take the top number, 165, and we're going to divide it by the tangent of 35. So when you put it into your calculator, you're going to type in 165 divided by the tangent of 35. And again, we're going to round that to the nearest foot. So the distance from the base of the lighthouse to the boat, in this case, is going to be 236 feet. All right, we're going to try one more together on the angle of depression. The last one we do together. So here's what it says. It says the angle of depression from the top of a building to a point 85 meters from the foot of the building is 64 degrees. It says find to the nearest meter the height of the building. In our setup on this one, we've got the adjacent side. We're wanting to find the opposite side. So hopefully on this one you use tangent. So the tangent of 64 equals x over 85. So in your calculators, you're going to type in the tangent of 64, which gives you approximately 2.0503. You're going to multiply that by 85. So to the nearest meter here, x is going to be 174 meters. And that's going to be the height of the building.